This activity is intended to be a review for your upcoming workbook assessment. So I would ask that you complete the problems and then use the video as an opportunity to check your understanding. If you get stuck on a problem and need additional help, then watch the video to the place where you understand how to complete the problem, turn the video off, complete it, and then turn the video back on to make sure that you have completed the problem correctly. So for problem number 1, we are told that the length of x is 10, and they're asking to find the value of y. So there's a couple ways of doing this. I'm going to take the approach of a proportion by setting up corresponding sides. So going from m to n, 8 goes to 12 as 10 goes to y. And then we started doing proportions back in August. So solving a proportion, we would cross multiply. So we would take 8 times y and 12 times 10. So 8y would equal 120. Divide both sides by 8 to undo the multiplication problem. And y is 15. Another way of doing this problem is that you could have, since we're going from left to right, the scale factor is going to be larger than 1. So we could have taken 12 divided by 8, which is 1.5. So 8 times 1.5 equals 12. So we could have also taken the 10 times 1.5 and found that y is 15. So 2 different ways of getting to the answer for number 1. In problem number 2, they're asking to decide between the 2 shapes P and Q which proportion would work. So we are told that EF is 10, HG is 5, LK is 7, and IJ is M. So I'm going to take the same approach by going to corresponding pieces to set up a proportion. So 5 goes to 7 as 10 goes to M. Now this is one way of setting up this problem, and I could have done, let's say, in the same shape and gone 5 to 10 and 7 to M, and that would give a different proportion. 5 goes to 10 as 7 goes to M. If you look at both proportions and if you do the cross multiplication, what you would end up with is 5 times m is equal to 7 times 10, the one on the left, but also the one on the right, you would also have 5 times m is equal to 7 times 10. So I'm bringing up the fact that there's multiple ways of setting the proportion up, and what's key here is that when you do the cross multiplication, you have to have 5m equals 7 times 10. So if you look at A, you'll notice that we don't have 5m, we have 10m, so A does not work. In D, for example, D does work because I have 5m and then 10 times 7, which is what I'm looking for the other side. B also works because again I have 5 times m going one way, 7 times 10 the other way. E does not work because you have 7 times m. C does not work because you have 7 times m. And F does work because you have 5 times m and 7 times 10. So there are 3 that work here, B, D, and F. Problem 3, and the figures shown, the lines F and G are parallel. And you're trying to figure out what angles are going to be supplementary to angle 3. So when we talked about these angles, we discussed the fact that vertical angles are always the same, and the angles that are next to each other are usually different, and the only time they're going to be the same is if they're all 90s. So the red angles are the same, the blue angles are the same. If I have one of each, then they add up to 180. If I translate the angle markings down from G to F, angle 5 and 8 will be marked in red. Angles 6 and 7 will be marked in blue because 3 and 2 are. So what you're looking for are the angles that are supplementary, which means they add up to 180 degrees with angle 3. So since angle 3 is blue, I'm looking at all the angles that are red. So angle 1 and 3 would be 180. 3 and 4 would be 180. 3 and 5 would be 180, and 3 and 8 would be 180. So angle B being blue, I'm going to pair it up with all the red angles. Problem 4, angle DEF is dilated with center O and a scale factor of 2 to create angle D prime, E prime, F prime. The measure of angle DEF is 54. What is the measurement of angle D prime, E prime, F prime? And the answer is also 54 degrees. The example that I give in terms of my reasoning, anytime I go down to like a copy machine and I make a copy of a triangle, make it, let's say, larger or smaller, what doesn't change are the angle measurements. When we do a dilation and we do the transformations, the line of an angle, and then we dilate the smaller shape to make it the bigger shape, when that shape is made into a bigger shape, what's going to match up are going to be the angle measurements. The angle measurements don't change. If they did, then we would run into a problem. For example, if I would have, let's say, these numbers here for an angle, and then all of a sudden I use a scale factor of 2, and then all of a sudden all the angles double, that would definitely break some of our rules. First of all, some of the angle measurements would not be 180 here, which is our angle rule for triangles. So again, doubling angles doesn't happen here. The angle measurements stay 30, 60, and 90 degrees in this example. All right, so triangle EFG is dilated. Triangle E prime, F prime, G prime. Find the value of Y. So the first thing you should look at here is compare corresponding sides. So based on the lettering, they're saying that EF and E prime, F prime, those are the corresponding sides, so I marked them the same. FG and F prime, G prime would be considered corresponding sides. So I would set, again, two ways of doing this. I would set a proportion as one way. So 5 goes to 15, as 7 goes to Y. And then I can solve this by doing cross multiplication. So 5 times Y is equal to 15 times 7. So 5Y equals 105. Divide both sides by 5 under the multiplication problem. And so Y will equal 21. Another way of doing it is to actually see if there's create a scale factor between the corresponding sides. You have two choices. You can do 5 divided by 15 or 15 divided by 5. So there's always two choices. You're going from a smaller shape to a bigger shape, so that means I need the scale factor to be more than 1. So 15 divided by 5 is 3. So if I take the 7 times the 3, which is our scale factor, then the length of Y is going to be 21. So again, two ways of doing it, and sometimes just find the scale factor and multiplying it is the easiest. Sometimes you have to use a proportion because you don't have another choice. All right, so problem 7, quadrilateral ABCD is scaled to polygon A prime, B prime, C prime, D prime. Which of the scale factors will create a smaller image? Explain your reasoning. So, when doing shapes that are same, let's say I have a 6, 7, and 8, if I want the shape to be, let's say, the same shape, that means the scale factor is going to be 1. If I have a 6, 7, 8, and I want the lengths to be smaller, Then let's say I would multiply each of them by half, so it'd be 3, 4, and 3.5. If I want them to be larger, then I'm going to be multiplying by a scale factor that is more than 1, let's say 2, which makes it shapes 12, 14, and 16. So I'm looking for, to make the shape smaller, I'm looking for scale factors that are less than 1. So A is less than 1, that's 7/10, and that is the only one. 5/4 is 1.25, so that's more than 1. This would give me an equal shape, or congruent shapes, and D would give me a larger shape. So A is the only one that works here. Problem A is asking you to say that polygon N is a scale copy of polygon M. If the value of X is 15, what's the scale factor? So again, these are the corresponding sides. There's always two choices, so I can go 9/15 or 15/9. And it says that N is the scale copy of M, so M is the bigger shape, N is the smaller shape. So basically I'm moving from left to right, so I'm looking for a scale factor that's going to shrink it, and that would be 9/15 or 3/5. Problem 9, polygon A prime, B prime, C prime, D prime, E prime is a scaled copy of polygon A, B, C, D, E after dilation centered at F. What is the scale factor? So I look for a pair of corresponding sides. Again, I have two choices here, 3/5 or 5/3. I am going from a smaller shape to a larger shape. So that means I need a scale factor that's greater than 1. So the answer here is 5/3. Problem 10, triangle A prime, B prime, C prime is a scale copy of the triangle ABC. Which of these scale factors will result in an image that's larger than the original? So I'm looking for a scale factor that is greater than 1. So that the answer to this problem is D. These two numbers here, A and B, would actually give me a smaller shape because the scale factor are less than 1. And C would give me congruent shapes. The shape would not change in size at all. I'm going to stop here due to the video time, and I will pick up for the latter half of the review in the next video.